Hi, in this video, we're going to do an introduction to data types in Python. So we have talked about float division, and it gives an integer result, and the true division, which yields a floating point number result. So that's integer and floating point numbers. They are our first glimpse of what data types are in Python. So let's look at these in a little more detail. So in integer, as we already talked about, is a number without a decimal point, and it can be positive or negative. And we've seen examples of them, such as 1. Negative number would be a number with a hyphen in front of them, and then they can be very big. Now, one interesting thing is about that in English, we see numbers that if they are more than 3 digits, we might insert commas every 3 decimal places, such as 1,000. We insert a comma here before the 3 zeros, I guess. Now, you actually can type something like this in Python, okay, like what I did here. So this, at first glance, it might look like the number 1,000, because that's what we're used to in English. But when I print X out, we are going to be in for a surprise, because we see something that is very different. I mean, this is definitely not 1,000. So in Python, we cannot use what's called the thousand separator. Okay, don't do it. This actually, the reason it's a valid syntax in Python is because it actually defines what's called a tuple. We'll talk about tuples later, but again, just remember, this is not how we specify a number or an integer in Python. So that's integer. What about floating point numbers? Well, we've seen floating point numbers. It's just a number with decimal points. And again, it can be positive and negative like integers. And now there are several ways to specify floating point number. One is we can say, to specify 1.0, we can actually just say 1 point, and we don't have to put 0 there if it is just 0. So this is valid, but to me, this is not quite readable because, well, I mean, it's not immediately obvious there's anything after the decimal point, even though implicitly there is a 0 there. So while this is valid syntax, I would suggest that if you want to specify 1.0, then you say 1.0 rather than just 1 point. And the other way is, floating point number is 3.14. If you want to specify negative floating point number, put a hyphen in front of it, just like a negative integer. And if you run that, you'll see, yeah, these are printed out as you would expect. And like I said before, even though we have one point here, this is actually 1.0. Now, there is another way to write floating point numbers and using the scientific notation. So we start with a normal number as we did before, and we follow by the letter E, and then we follow by the intended power of 10, which is what scientific notation is, right? So, for example, 1.0 E1, that is equivalent to the number 10.0. That is because we, it's the number, which is 1.0 times 10 raised to the first power. So that is 10. Another example here is that 1e minus 2. So the intended power of 10 can be a negative number, right? And so this number would evaluate or would represent the same number as 0.01, because, well, again, we start with 1 and we multiply by 10 raised to the negative 2 power. 10 raised to the negative 2 power is 1/100th, or in this case 0.01. And then lastly, another example here, this is 456 multiplied by 10 raised to the 5th power, because it's a E5 here. So that is this number, I believe is 45 million. And then actually, yeah, 45 million and then 600,000. And the trick or the rule to derive at the actual value of a floating point number in scientific notation is that we have to identify the decimal point in the original number, and then we move that decimal point to either the right if the power is positive, or to the left if the power is negative by the number of places specified in the power. And then we fill it with 0 if necessary. So for example, the for the 1 here, because the power is -2, then we start with 1. The decimal point is 1 point, and then we move it to the left by 2 places, which results in the 0.01. And for another example here, the decimal point is after 6. So, and because the power is 5, we move the decimal point 5 places to the right. So 1, 2, 3, 4, 5. And that gives us this number that we have here. And obviously, if we want to verify that we derive these values correctly, we can use Python to do that. I can print them out, for example. So I can run it, and here they are, and they match what we expect. And with all of that, I like to make sure that you understand them. So here are a few numbers as specified in Python. I would like you to first manually derive their values, and then you can use Python to print out the actual values and make sure that they match what you derive manually. So please pause the video and give that a try. Alright, assuming you've done that, there's really nothing too tricky here other than this one. Again, this is not a number, it is a tuple in Python. So integer and floating point numbers are the two main types of numbers in Python. Now, other than numbers, there are other types in Python as well, and we've actually seen another type, and that is anything that's between quotes. They are these string literals. So, for example here, right, we can say a message, we can assign the string literal hello world to the message, or a name to the variable name. Now, one thing I want to say before we move on is that, well, in Python we often refer to string just as str, and we'll very soon see why we do that. So anyway, now if we talk about strings, then there's one thing that we probably haven't done before, but it's really a common operation for string is that we can put multiple strings together. And we do that by doing a string concatenation using the concatenation operator, that is a plus sign. Okay, so yeah, this is the same plus sign that we use to add two numbers together, but when we add two strings together, we concatenate them together. So for example, I can let's say print, I'll say Zibin is a teacher here. Okay, and that basically adds these two strings together. So hopefully let's run, and here it is. Now you notice that there is no space between these two strings, where we probably normally do want a string. So remember, when we're doing string concatenation, these strings are put together exactly as they appear. So because there's no space here and there is no space here, therefore when the one string the resulting string does not have a space. So if we want a space, we have to put a space in either one of these, and then in this case there should be a space. Now you might ask the question is, okay, well, since this is just going to print out Zbin is a teacher, why do we use string concatenation? Why don't we put everything in a single string? Well, so let's look at another example, and in this case we're going to put the name Zbin, the string, in a variable, and we are going to actually print the name out plus is the teacher out. So instead of using Zbin here, we're going to say name. Now in this case, yeah, we when we run it, print out what you expect. Zbin is a teacher. Okay, so that's all good. I haven't done anything new here. Now what can be then done is that what if we want to say a different name, you know, that person is a teacher. Let's say, you know, Mike is a teacher. So we only change the name variable. We don't change what's actually being printed out, but the fact that we just changed the value for that variable means now we are printing out a different sentence. Say Mike is a teacher. So you can start thinking, hey, there might be some use for that, right? Because, for example, in a lot of the form letters, which are basically just addressed to, you know, dear Zbin, dear Mike, dear John, whatever, and then the body of the letter will be the same, right? So it's actually quite often that, you know, part of what you want to print out is in a variable, say a name, different name, and while a big part of what you want to print out is just some sort of string literal that does not change between the different message. So in those cases, then it's quite useful to concatenate the part that changes with the part that does not change.